Open source tool capabilities for CAE, CFD. By Future CAE Technologies. Future CAE Technologies is a fast-growing engineering software and consulting company headquartered in the United Kingdom and its software development center in India. Future CAE Technologies also provides CAE services and training using open source tools. Why open source? Using open source has several advantages such as no license cost to be paid by the user for using open source software. Source code can be modified according to our requirement, unlike commercial softwares where the source code can be used but can't be viewed or modified by the user. Open source softwares are also developed by well-reputed organizations, research institutions for their research purpose, and they have made it available in the public domain. Source code is also continuously monitored by developers for its robustness and improved in each updated versions. Limitations of open source are: most of the open source softwares have TUI, text user interface, which makes it difficult for new users to use. Customer support is less compared to commercial software's support. Let's talk about exploring more about open source free softwares. Some of the open source free software are Codeaster, Calculix, Elmer, Freeform++, and many more. Codeaster is developed by R&D Électricité de France, EDF, the largest company producing and distributing energy in France. Calculix is developed by MTU Aero Engines, Germany. Elmer is developed in collaboration with Finnish universities, research institutes and industry. Freeform++ is developed and maintained by Pierre and Marie Curie University Public Research University in Paris, France. Calculix and Codeaster are more predominantly used in industries. Mainly we support our customers using Calculix. Calculix uses a booksim format. Available in Windows and developed in English, unlike Codeaster that is available in French. Calculix fee solver capabilities are linear static, nonlinear analysis, transient analysis, modal analysis, fatigue analysis, buckling analysis, thermal analysis, fluid flow analysis. Few Calculix case studies. Left side image shows the result of von Mises stress in engine piston for linear static structural analysis of piston during combustion stroke. Right side image shows von Mises stress contour of crane hook for linear static structural analysis for lifting loads. Left side image shows the von Mises stress in 3D steel bracket for static loading. Right side image shows von Mises stress in turbine blades for pressure loading on turbine blades. Let's talk about exploring more about open source computational fluid dynamics software. Open source CFD software are OpenFOAM, CodeSaturn, SU2, and many more. OpenFOAM is developed at Imperial College London. OpenFOAM has an extensive range of features to solve anything from complex fluid flows. CodeSaturn is developed by R&D Électricité de France, EDF, the largest company producing and distributing energy in France. This software is limited to simple problems and has limitations in solving compressible and combustion problems. SU2 is developed by a group of professors from Stanford University, Imperial College London, and many other universities. Mainly we support our customers using OpenFOAM as it is widely by industries. OpenFOAM capabilities are incompressible flow, compressible flow, multiphase flow, combustion, rotating machinery, heat transfer, electromagnetics, stress analysis. Few of our OpenFOAM case studies. External aerodynamics, flow around Ahmed body. The Ahmed body is a benchmark model widely used in the automotive industry for validating simulation tools. The objective is to validate the drag coefficient of steady state incompressible turbulent flow around the Ahmed body for slant angle of 25 degrees as shown using OpenFOAM. Left side images show the geometry and dimensions of the model. Right side top image shows the pressure on the surfaces of the Ahmed body. The image below that shows the streamlines capturing recirculation behind the body. The table shows a comparison between experimental result and CFD using OpenFOAM result. Variation with experiment is 1.25%, which is in the acceptable range. This case study shows the animation shown here is visualization of repeating pattern of swirling vortices for the flow of air over a circular cylinder at Renault number equal 180 with OpenFOAM, von Karman vortex. This case study shows the animation of the CFD transient simulation of mixer vessel using dynamic mesh, moving mesh, and arbitrary mesh interface, AMI, simulation across disconnected, adjacent, mesh domains, between stator and rotor with open foam.
Left side image shows velocity vector for CFD analysis of centrifugal pump done using multiple reference frame method and open foam. Right side image shows velocity streamlines for flow around a motorbike capturing low pressure region behind the motorbike. If your organization thinking to evaluate your design studies using open source fee/CFD, please contact us for more information. Thank you for your valuable time.